Let's talk about reducing and non-reducing sugars, and we'll try to identify what are those kinds of sugars. A reducing sugar basically can reduce a silver ion. A non-reducing sugar cannot reduce a silver ion. So what are these? How do you identify these reducing sugars? A reducing sugar has an aldehyde, a ketone, or a hemiacetal group. Okay, if there is aldehyde, ketone, or a hemiacetal, remember the hemiacetal carbon with the OH group and OR group, they are hemiacetal. A non-reducing sugar does not have one of those groups. So a non-reducing sugar could be acetal group. If the sugar has acetal group, there would be a non-reducing sugar, like a glycosidic linkage. Okay. All right, so this is disaccharides. So we're going to learn about few disaccharides. One is called maltose. So maltose, again, they are two sugar units, which is two glucose units. Together forms disaccharides. Now here you have a carbon, and then here you have another carbon, and then between that you have oxygen. Now for this carbon, this group is a OR group, OR group. So this is a acetal group. Okay, it is an acetal. For this carbon, it has only one oxygen. So this is going to be acetal group for this glucose molecule. And this is a alpha because it's facing down. It is a alpha 1,4,1,4 glycosidic linkage, which is the acetal group. Okay. Now this disaccharide means two sugars, two monosaccharides. So these are both glucose, and there is a carbon here in the glucose, oxygen R and OH. What do you consider this? Is it acetal or hemiacetal? Carbon with oxygen OR and OH. So this is a hemiacetal. Do you think this is a reducing sugar or a non-reducing sugar? This is a reducing sugar. Remember, this has a hemiacetal group. It also has an acetal group, but also has a hemiacetal group. So that is a reducing sugar. So this can reduce silver ions. Okay. Maltose is a disaccharide and it is a reducing sugar. What about cellobiose? Cellobiose again also two glucose units, but their glycosidic linkage is different. So it's a beta, just facing up. Okay, with regard to the first glucose unit, its glycosidic linkage is facing up. It's a beta. And here it is alpha facing down. That's the difference between maltose and cellobiose is the alpha or the beta position of the glycosidic bond. Now this is again, here's an acetal group, and at the same time it also has a hemiacetal group over here. So the cellobiose is also a reducing sugar. Okay, and this is lactose. So lactose doesn't have glucose. It has a galactose, D-galactose. So this is galactose. Remember which is facing up. D-galactose, which is a C4 epimer of D-glucose. It also has a glycosidic linkage, beta facing up, 1,4. This is number 1 and this is number 4 for this one. 1,4 glycosidic linkage. And this is also a reducing sugar because even though you have an acetal here, you have a hemiacetal part of the other molecule, other D-glucose. So lactose is two monosaccharides. They are D-galactose and D-glucose. Okay. Lactase is an enzyme that cleaves the glycosidic bond in lactose, and this is also a reducing sugar, lactose. And this is sucrose. What is sucrose? Sucrose is these two monosaccharides. Sucrose is made up of glucose and fructose. So alpha linkage at the glucose facing down, and it is a beta linkage at the fructose. Okay, Do we have acetal here for this carbon? This is OR. OR, there is acetal group, and for this carbon there is a OR and OR. Both of these have acetal groups, doesn't have acetal. So sucrose is a non-reducing sugar. It's not a reducing sugar. Okay, so the criteria for a reducing sugar is it should have a hemiacetal ketone or aldehyde group, but this one doesn't have any of those, and both of these are acetal groups, so it is not a reducing sugar. And polysaccharide is a sugar that consists of more than 10 units of monosaccharides. So polysaccharide starch is made up of 20% amylose and 80% amylopectin. Okay, so this is amylose. Amylose also. So these are 3 subunits of amylose. This is also glucose units. 1,4 glycosidic linkages they have. Composed of chains of D-glucose units, about 20% of starch is amylose. And then this is amylopectin, and this is an unbranched chain of glucose units. And this one you can see it is a branch chain, amylopectin. It's about 80%. 5 subunits of amylopectin. 1, 2, 3, 4, 5. In addition to 1,4 glycosidic linkage, it also can have 1,6 glycosidic linkages, which is again a polysaccharide. And cellulose. Cellulose is a structural material of higher plants. They also have glucose. It's a beta 1,4 glycosidic linkage, 3 subunits of cellulose. And in addition to that, you can also see intramolecular hydrogen bonds in cellulose. And these are the sugars we find in RNA and DNA. This is beta D ribose. Beta, because this carbon is hydroxyl group on this carbon is facing up. And this is also beta D 2-deoxyribose. So you see this is a ribose, and then the hydroxyl group at the second carbon is not there. That's why it's called at the 2-deoxyribose, deoxyribose. Okay, D-ribose is a sugar component of RNA, and then the D2-deoxyribose is a sugar component of DNA. Okay, so that concludes our chapter about carbohydrate. And now you can do your homework also. And this is an example of an amino sugar. In amino sugar, in addition to the alcohol groups, you can see amine groups. They have one or more OH groups replaced by amino groups. Here's an example of an antibiotic, gentamicin, an antibiotic. Okay. All right, then that's the end of the carbohydrate chapter.